Okay, so we were at number 3. So we had discussed the question type number 3. Let's quickly go in and solve a problem or two from this question type. So once again, what do we have in here? We have a particle which is in equilibrium, and it is experiencing the static frictional force. So which means that we have to account for the fact that the static frictional force would be equals to mu mg if we are about to slip situation. If it's not about to slip situation, then the static frictional force would be less than mu mg. Okay, so let's go ahead and solve this one. We did or we did not do this one. We have not done this one. So let's go ahead and solve this question, please. By the way, Chavi, the force between two charges is given by how much beta? Do you know the equation for that?
So is it k q2 by r square?
Right, exactly. K q1 q2 by r square. And Ruchika, beta, do you remember the value of K?
No, sir.
Okay. That is 9 into 10 Newton per meter square, Newton meter square per Coulomb square. 9 into 10 to the power 9.
So 12 centimeter.
12 centimeter, okay? So we talk about limited equilibrium. So I think what they mean to say is this is the limiting scenario. It's about to slip situation. So Ruchika, beta, I think that's how you have done it, correct?
Yes, sir.
Okay.
Is it coming
Coming
exactly
exactly
12
12
centimeters?
centimeters.
It's coming to be exactly 12 centimeters. Yes, Peter. Peter, sorry, I couldn't hear you. Chavi.
Is
Is
it
it
exactly
exactly
12
12
centimeters?
centimeters?
Because
Because
I'm
I'm
getting
getting
approximately.
approximately.
Okay, you have taken the value of G as 10.
Yes,
Yes,
sir.
sir.
Okay. This is what we have. So let me strike it out. So 10 to the power 9, 5, 4. So we have 10 to the power 4. Sorry, I'm just going to keep it on that side. So what do we have? L squared. So L is 3 into 2 into 2 into 10 to the power minus 2. That's coming out to be exactly 12 into 10 to the power minus 2 meters or 12 centimeters. Just check with them. So mu mg is coming out to be 10 to the power minus, or mg is coming to be 10 to the power minus 1. Mu is 0.25. This is 1 by 4. So you take 4 on the other side. Then L square is equals to 9 into 4 into 4 into 10 to the power minus 4. You take square root, you'll get 3 into 2 into 2 into 10 to the power minus 2. So that is 12 into 10 to the power minus 2 meters or 12 centimeters. Yes, Peter? Clear?
So I'm checking.
Okay,
Yeah.
yeah.
Okay. So let's look at some other questions. Let's solve this one. So once again, in these scenarios, we are, well, this question could have been in the next one, but here, pretty much all the forces that we're looking at, this is a simpler situation. The next question types will slowly, incrementally increase in complexity with the forces acting at different angles. But for in this question, looks like the force F that the man is holding, it is acting at some angle. But anyway, let's read through it. By the way, does the angle make any difference? Angle at which the boy is pulling the string, does it then make any difference, Peter?
I don't think so.
Okay,
So I'm getting 30 newtons.
13 newtons. So Chika beta, let's quickly think through this one as well. Chavi, beta, can I discuss it a little bit? Or shall I give you some time?
Oh, no, sir.
So let's say this angle is theta, Ruchika, right? So
So,
beta,
focus for a point.
yeah. So let's see, the boy is not moving, right? So we assume that the frictional force, whatever the component in this direction, right? So this is your force F or tension T. What are they asking? The force F that the boy can exert, right? So the force F F cos theta is in the vertical direction and F sine theta is in the horizontal direction. So the boy will experience a force, the reaction force of F sine theta in the forward direction. That means the friction between the boy and the block has to prevent the boy from moving in that direction. Right? The frictional force between the boy and the block must be F sine theta. In other words, the boy is actually exerting a force of F sine theta in this direction. Correct, Nabita?
Yes, sir.
Okay. So which means that as far as the boy is concerned, let's see. So if you do the free body diagram for boy, then you have boy is 4 kgs, right? So it's 4 Gs acting downwards with a normal force acting upwards. This is N1, and there's another force acting in that direction, that is F cos theta. Okay. Horizontal forces are balanced. This is the frictional force acting, and this is the F sine theta. Chavi beta, you're okay with this now?
Yes, sir.
Okay. So let's quickly see. Now, let's quickly draw the free body diagram for the block. So the block will experience force of N1 in the downward direction.
So one thing for the boys free body diagram, there is no frictional force, right?
Beta, there has to be, otherwise, if the rope is at a tangent, then the boy will will accelerate in the horizontal direction, right?
Yeah, so that is okay, but then if it's not okay, fine. Yes, sir.
Yeah. So I know what you're saying. You're saying so there is the coefficient of friction is not given between the boy and the block. So we'll assume it's large enough so that it prevents uh, the boy slipping on the wood. Okay. So this is N1 and this is 5G acting in the downward direction, and tension is acting. So in this direction, you have two forces. One is your F sine theta. Another is your force F, because after all, the tension is T is same as F everywhere. The frictional force on this one is F2. Let me just write F1 and F2. If we remove this F here, this is F2, and the that's it. I think we have covered all the forces, and of course there is the N2 is the reaction force from the ground onto the block. So for the block, if I do the force balance, I'm going to say block. So N2 is equals to N1 plus 5. And in the horizontal direction, so F plus F sine theta will be equals to F2. Right, beta? Now, let's quickly write the equations for the boy. So boy, we will have the n1 in the vertical direction, n1 plus f cos theta is equals to 4g. That means n1 is equals to 4 minus f cos theta. Now, as far as the horizontal direction is concerned, we have f1 is equals to f sine theta. And that's why we wrote f sine theta here, because of this. So this equation we have already used up. We've already used up in writing this force on the block as f sine theta. So now, if you look at n1 is equals to 4 minus f cos theta. So if I were to write n2 will be 5 plus 4, that is 9, minus f cos theta. So let me put it back in the second equation. So f is equals to, second equation is f2 divided by 1 plus sine theta. Okay, 1 plus sine theta. Now, what is the maximum value of f2 for a given theta? For a given theta, maximum value of f2, because we are after all, we're trying to figure out the maximum force that the boy can apply. So there'll be mu, about to slip situation, there'll be mu times n2. n2 is 9 minus f cos theta. Correct, beta? So far, you guys with me?
Yes, sir.
Okay. Now we are going to figure out for what value of theta is this force going to be maximum. So we have mu 9 minus, so we need to actually take force F on the other side. So let's quickly rearrange so that we have F on the left hand side and the expression involving theta on the other side. So we'll have F 1 plus mu cos theta divided by 1 plus sine theta is equals to mu 9 mu upon 1 plus sine. This is 1 plus. It is like this. Okay, beta? So what do we have? So force will be 9 mu divided by 1 plus sine theta plus mu cos theta. 1 plus sine theta plus mu cos theta. Is that right?
Yes, sir.
Okay. So let's quickly figure out for what value of theta would this be maximum. The sine theta. So I have an expression, let me call it G. G of theta is sine theta plus mu cos theta. So dg by d theta is equals to cos theta minus mu sine theta is equals to 0. Now, so what do we have? This is, let me also figure out the d2g by d theta 2. So let me just, to figure out whether we are dealing with the maxima or minima at theta equals to 0. At theta equals to 0, the value is 0.5. Value of g theta is 0.5 for theta is equals to 0. And for theta is equals to 90 degrees, what do we have? Cos 90 is 0, so that is 1. Right? And for tan theta equals to 1 by mu, so for tan theta equals to 1 by mu, we will have, question is, are we going to have like this, which is not possible. So we're going to have like this. So let me explain why that is not possible. But for tan theta equals to this, I can write, by the way, d2g by d theta 2 would be sine theta minus sine theta minus mu cos theta. So which is minus is outside. So if you take cos theta out, this is a positive quantity. So this is negative. Oh, this is negative. If this is negative, then this is a maximum. Now we want this to be minimum. We want this to be minimum. So minimum value, so this is actually like this. Correct, beta? So let's see what happens at mu is equals to 1 by root 2. So we'll have 1 by root 2 plus 0.5 by root 2. Which is interesting actually.
Sir,
Yes, beta?
सर हमने ट्रिग्नोमेट्री में एक वो सीखा था राइट फॉर द मिनिमम मैक्सिमम ऑफ लाइक a sin theta plus b cos theta वाला फॉर्मूला the minus root a square plus b square we can apply that here right so we can say the coefficient of sine is 1 and coefficient of cos is mu and then we want to find the maxima right so we can just say root of 1 square plus mu square is
That is a different problem. We'll come to the next question type. But here, simplistically, if you see the minimum value is 0.5 when theta is equals to 0. So when the man is standing just right here, that's when this force is minimum. Okay? And Ruchika, that's what you have assumed, beta? You have assumed theta to be 0?
Yes, sir.
So it definitely seems like we have gone through some very complex calculations. And question is, can we quickly or can we logically come to the conclusion that theta should be 0 for the man to apply the maximum force? The man to apply the maximum force, theta should be 0. How do we make that conclusion? When theta is 0, right? So when theta is 0, he is not applying any force in the horizontal direction, right? So f sine theta is 0. So it's only the tension, and the tension is maximum, but we had to figure out which scenario is maximum. I cannot think of any other way at the moment to say that this would be the maximum force when theta is equals to 0, other than do it mathematically, just like we did here. Now, I wish there was a better way. I'm sure there is a better way to make that conclusion. Okay, but let me ask you guys a quick question. Scale of 1 to 4, do we know what we were doing here, or did you guys well disengaged here? Scale of 1 to 5? 5 means no, absolutely in tune. We know what was going on and we know the methodology, even though this is a JEE mains question. So obviously we couldn't afford this much time. Correct, no?
Yes, sir.
But so you had to take a quick guess here, right? For what value of theta will this be maximum? Right, Beda?
Yes, sir.
Okay, Chavi Beta, have you understood the approach, even though unfortunately you have to go by theta equals to 0 if it is JEE main question?
Yes, sir. So can you just explain the part where you do the graph one more time?
Sure. So the equation we got was f is equals to 9 mu 1 plus sine theta plus mu cos theta. We said for f to be maximum, by the way, this was the maximum force under the limiting conditions, right? Now we are trying to prove that this will be maximum when theta is to 0. So at theta equals to 0, sine theta plus mu cos theta is 0.5. At theta equals to 90 degrees, this will be 1. Now we figured out a value. So let's call this expression as g theta. So I did dg by d theta is 0. So that gave us that this is maximum when tan theta is equals to 1 by mu. So how did I figure out whether this was the maxima? I calculated d2g by d theta 2, and that was negative for all values of theta, right? So so what does that mean? So that means that this is actually maxima. But if you have to just see whether this is maxima or not, let's just quickly see sine theta plus cos theta, mu cos theta. If you take cos theta out, you will get tan theta plus mu, right? So cos, in fact, let me do it this way. If tan theta is mu, then we have sine theta is equals to 1 upon square root 1 plus mu squared, and cos theta is mu upon square root 1 plus mu squared. Let me just check something. Yep. So what do we get then? So we get this as square root of sine theta is 1. So I'll get 1 by square root of 1 plus mu squared. And at the top will have 1 plus mu squared. So you get square root of 1 plus mu squared, which is greater than 1. So that means the graph at this value, tan theta equals to 1 by mu, is actually greater than 1. This is a maximum. We are interested in minimum. Minimum value is 0.5. Okay. Typically, in the problems where you have to figure out dg by df by d theta, df by dx for maxima or minima, typically you run into scenarios where you get the desired extrema, right? So if you were trying to find the minimum, you will typically have scenarios in physics where you get the only one minimum, no maxima, minima, where you have to determine whether it's a maxima or minima. Things are simpler. Here in this scenario, you can see it in different ways, but d2g by d theta 2 would be the most reliable way to see whether at this theta you have maximum, right? But what we are interested in this scenario is the minimum, right? So for f to be maximum, sine theta plus mu cos theta should be minimum. Denominator is minimum, then we get the maximum value for the force f. So let me just quickly see how, let me just give me a quick second here. looks like nobody has done the math to convince that this is going to be the scenario. But that's okay. So let's move on. Unless you guys have any questions. Do you guys have any questions? No questions. Okay. Let's do. This should be fairly simple, right? The coefficients of static friction between a wooden block of mass 0.5 kg and a vertical rough wall is 0.2. Then the magnitude of the horizontal force that should be applied on the block to keep it adhered to the wall will be how much? So let me quickly draw the picture and you guys can actually tell me the answer right away. It's very simple. This is what we have done. This is the block. So 0.5 into 10. 5 Newton forces. A gravitational pull is acting downwards. We are applying this force F, and this will be okay. So in the limiting scenario, this will be mu F. Correct, Peter? Because the normal force will be equals to F. So the frictional force is mu F. So mu F is 5 newtons. So F is 5 divided by 0.2. Yes, Peter?
Yes, sir.
So 25 newtons. Shavi?
Yes, sir.
Okay. That's what you got as well, no, Peter? Let's take a quick look at this problem. So now let's just kind of discuss the problems rather than solving them in the entirety. So I'm going to read through the question. It says two masses, 5 kgs and 10 kgs connected by an inextensible string over a frictionless pulley are moving as shown in the figure. Okay. The coefficient of friction of horizontal surface is 0.15. The minimum weight M that should be put on top of M2 to stop the motion is how much? Right? Minimum. That means limiting friction. Right? So what will be the frictional force between M2 and the ground? There will be mu times the normal force. Normal force will be M plus M2. Correct, Namita? M plus M2 times G. And that will be equals to M1G. Yes?
Yes, sir.
Shall we be done? So the frictional force in the limiting scenario, this will be mu times M plus M2 times G. Because everything is in equilibrium, so the tension T will be equals to that. And if you draw the free body diagram of M1, you'll come to the conclusion.
So yes, sir, I got it.
Right. So since there is no friction force here, we'll assume that this is not touching the vertical face, and this will be M1G. So so we can do the rest. Let's look at anti-abhyas questions. Oh, this is a good question. Do you guys want to give it an attempt? And then we'll take a break here. We'll resume tomorrow after this problem. So please solve this one. For the students who will watch the video on YouTube, the important thing is that you approach the physics in a fairly structured manner if you want to build up your concepts in a fairly solid manner. Okay, so hopefully you will see that the structured approach that we are taking will help you clarify your concepts and problem solving skills. Right, it's very important that you build the problem solving skills in the correct manner. So in any case, you can subscribe to the website, and you have about 10,000 questions.
Sir, all systems are in equilibrium, right?
So let me go back to the live class for a moment. All these, yes, everything is in equilibrium. Yes, all the masses are in equilibrium, M1, M2, and M3.
So 50 newtons.
Yes, sir, 50.
Okay. So you have taken you figured this out, no, that the maximum frictional force is mu mg, right? A component of that is going to be providing the force in this direction, and component will be providing that direction, right? Or have you guys done mu mg in this direction, mu mg in that direction, and then take the net frictional force?
Sir, I just assume कि like जो M1 M2 है जो भी pulling इन दोनों से resultant force उसका जिस direction में होगा वहाँ उसकी direction में friction.
That is absolutely correct. And Ruchika, beta, that's how you have done.
Yes.
Okay, good. So figure out the net force acting on M3, and that should be equals to, and what is the net force, by the way? Square root of M1 square plus M2 square into G, right? G times square root of M1 square plus M2 square. I'm sure that's the force you got, right? So that is equal
Yes,
to
sir.
mu times M3G. Okay. Oh, it's not. What is it asking? It's saying then the frictional force on M3. Oh, so you don't even have to calculate. So it's not a limiting. So they have not given it's a limiting scenario. By the way, is it what is that? This is interesting. So the net force, is it greater than mu times M3G?
No, sir.
No, sir, it is less than that. So the total force is coming out to 15 newtons, whereas the maximum frictional force will go to 16 newtons.
Exactly. So so this is pretty excellent. So this is one of those scenarios which re-emphasizes what we were discussing earlier, that the static friction force, the maximum value is mu mg, but it can be anywhere between 0 and mu mg. It depends on how much force is actually trying to move it against the other surface. So if it is less than mu mg, then that's how much friction force will be. All right, beta, we'll take a break here and we'll resume tomorrow. So Chavi, beta, just hang on for a quick second. Ruchika, if you hang on for a quick second as well, beta.